Hello everybody, this is again Dr. Sergey Sarkisov, and I will be showing you now how to solve quadratic equations with different methods. In fact, I always tell my students that there are three primary ways to solve a quadratic equation. Okay? And let's specifically focus on one example. It's a lighter of multiple examples I can provide, but let's do this one. How about you see something like x squared, so the quadratic, right, quadratic term, and then maybe let's say minus a 3, okay, so there's like a constant term is equal to 2x, and so you're confused because like, hold up, how in the world is there a quadratic, a square term, and it's equal to this linear term, right? How are you going to have where you have the square term and the linear term equal to one another? In fact, think about it. If this wasn't there, this is just a linear equation, right? You just divide by 2, you get x equals negative 3/2. If this wasn't there, right here, the x term, right? You solve, you isolate the square, it's called, okay? You get x squared, if this wasn't there, you get x squared is equal to 3, and x is plus or minus square root of 3, right? Okay, now, we have a square term, a linear term, and a constant term. How do we deal with that? We manage that. Well, you know, one thing you can do is guess the answers. You can try numbers, you know, 1, 2, 3, 4, 5, -1, -2. And actually, from the ones I mentioned, there will be 2 that will work. But how do we know those are the only 2, right? So there's some depth into being able to solve quadratic equations, not just guess the answers, because usually you will not be able to do it easily, the guessing. So anyway, let me do this. The common way, and a tricky way in a sense, an insightful way, will be to do this. Let's solve by factoring. Okay, it's called by factoring. So that's what we're going to do first. Okay, before that, let me mention that we have, this is something called, we have a quadratic equation in standard form. So you have to put in standard form a quadratic equation. What is standard form? It's when you have something like a number, a coefficient times x squared, the x squared term, right, the square, the quadratic term, and then plus another coefficient times a linear term, x term, plus a constant is equal to, so you make it 0 on the right side. And 0 is probably the most important number in algebra. Not even the number 1, but the number 0. There are so many things that happen. There are the zeros, the polynomials. There's the zero product property. There's a lot of things that happen when you look at 0. Finding the x-intercepts, the y-intercepts of a graph. The points where x is 0, the y-intercepts, or the points where y is equal to 0, and those are the x-intercepts. A lot of different things, right? So 0 is just a huge number. I sometimes tell my students it's a number that happens after you understand the, you know, the natural numbers. You start 1, 2, 3, you're counting, and then when everyone leaves, when you're feeling alone, when you're feeling like a total 0, there's that concept of 0. It's an interesting way to kind of look at it in a development of psychological understanding of numbers. Okay. Anyway, so let's say we put this, we have to put in standard form the quadratic equation, and above ours is not, right? So let's do that. If x squared minus 3 is 2x, then x squared, let me actually write it one more time, minus a 3 is equal to 2x. And let's just keep it really simple, every step by every step. Let's subtract 2x from both sides. So we have x is only on the left side and get a 0 on the right, right? And what happens? You get x squared minus 2x. They're not like terms. You keep them separate. And minus a 3 is equal to, now this is 0. Okay, we put it in standard form. The next thing we do, we try to factor it the best that we can. So factor. This is, again, one way to do this problem. And factoring, here's a trick. I tell my students, you know, there's an AC method. There are different ways to do this. But my biggest go-to, what I tell students is, practice makes perfect on factoring. Not everything is like that. Okay, I don't believe everything is like that. Some things, some concepts somebody learns in a minute better than somebody spends a whole day learning it. And the way you're taught is important, and the tricks you're using, and just how insightful you are. Well, factoring, you know, if you just spend a lot of time factoring, 100 factoring problems, it's gonna make you better than if you have done only 5 of them. Let me show you what the idea is. You want to get squared, and the way to do sum of x times sum of, obviously we have 1 here, number 1. easy numbers, 1 times 1. So 1x times 1x. Basically, put a 1 here, put a 1 there. That's how you get the x squared. There's something called the FOIL method where you multiply this out, the first terms, that's going to be x squared, right? Let's just check that. Now, how do you get a negative 3 in the end, the c term? How do you make that negative 3? Well, factors of it are 3 and 1. There's not much more we can do with that. So let's put a 1 here, a 3 there. And then how in the world are we going to get a minus 3 and a minus 2x in the middle? This is the insightfulness that happens. So we need a minus on either a 1 or a 3. And let's do this. Because we have a more negative for the x, let's do minus a bigger number, minus a 3 and plus a 1. You see the thinking that that's going through my head? So these are the last terms. That is a multiplication. Product of those is a negative 3. Remember FOIL method. First, let me write it out. First, outer, inner, last. And this is actually not my favorite method for expanding, because my favorite method is saying multiply everything by everything, as I've told you before, which is basically the same thing for a 2 by 2 here. But FOIL method, first, outer, inner, last. This is the first. This is the last. What about the outer and inner? Outer is the outer terms. That's a negative 3x, if you see that. Correct. And what about the inner terms? The I for inner terms. That's a 1 times x plus x. So you see that work out to be 2 minus the 2x we wanted. So it's factoring nicely. Okay. So anyway, this is the factoring of it, right? So on the left side. So we have x plus 1. Let's write it out. X plus 1 times x minus 3 equals 0. Awesome. Now there's something called the zero product property. And I can just call it like the common sense property. Okay. Now what do I mean by that? Why common sense? Why is it not? I wouldn't really entitle it anything too much, but some people often, some books will usually say it zero product property. And what that is, okay, what it says is this. You'll see what I mean by that. If you're multiplying weird, different numbers, whatever they are, like 1.7352 times the square root of 11 minus pi, and you multiply those two numbers like this and that, multiply them together, guess what? What I just mentioned, those numbers, they're not going to give you 0. The only way to get 0 on the right side is if you get 0 for this one or 0 for this one. Does that make sense? If I multiply a bunch of things together, the only way to get 0 is to have something 0. So zero product property says, you know, if we have something, like let's say a number m times a number n equals 0, this is basically saying that m is equal to 0 or n is equal to 0, right? And of course, if that's the case, it goes out backwards the same way. So if and only if, right? One of those has to be true, the whole statement, that m is 0 or n is 0. In other words, we have x plus 1 has to be 0, right? And if that's not the case, then the only other option we have is, right, x minus 3 has to be 0. And that's really where we get this two solutions coming from. So, by the way, these are the only possibilities. So we have x is subtract 1 from both sides, negative 1, or x is equal to, possibly equal to 3. Only possibilities. Nothing else will work. For example, you may say, well, what if I try 100? I don't know. 100 plus 1 is not 0, and 100 minus 3 is not 0. Don't worry about what it is. It's not going to be 0, right? And we want 0 on the right side. So it has to be a negative 1 or a positive 3, and then it will work. Here we are. We have the answer. The solution is negative 1, comma 3. It's a combination of those two. Those are the two answers. X is negative 1 or x is negative 3. So the answer is that there are two possible solutions, negative 1, 3. Now, let's check. A lot of times people say, you know what, we can check the work. So checking the work means what? Again, I wouldn't always do this if I'm really comfortable getting the right answer, you know, if I'm confident. But if let's say you're checking, let's check x is negative 1, and let's make sure the left side, left-hand side LHS, but left side, and the right side are matching up, right side. So right side and left side. Right on the left side it was x squared, I believe, minus a 3. Go back to the initial. And right side 2x, okay? So x squared, which is negative 1 now, squared, minus 3, is a positive 1 minus 3 is a negative 2. And on the right side we have double, right, 2x, 2, oh, negative, they're equal. When one works, it satisfies the equation and solves it, meaning the left and right sides, like balance on a scale, would weigh out equally. Okay, equals, right? And then So on the left side, we have x, so 3 squared minus a 3 is equal to 9 minus 3 is equal to 6, right? On the right side, what happens on the right side? We have double the 3. And again, the 2 times x, 2 times 3, that's a 6. They're equal to one another. Not surprising to us, hopefully not. And so we have that, yes, these are the solutions are working. Rare occasions you want to check, because sometimes if you have like a square root, like a radical equation, you'll get new solutions, but guess what? One of them or two of them may not work, right? Anyway, there's one answer. There's an answer, and guess what? We solved it by factoring. Now you're like, well, okay, cool. Well, there are other ways of solving. So what I'm going to show you now is solving another possible way this problem. Let me show you that. Ready? Let's try solving. Okay. Now, by using the quadratic formula. In other lectures, I've already proven to us the quadratic formula. So let me do this let me just say quadratic formula. 1 second. Quadratic. So we're going to use quadratic formula. Let's remember what it is, what it states, right? So it's a way of solving this problem. Okay, if we have x squared instead of the quadratic x plus c equals, you're given this quadratic equation. Guess what happens? We know, knowing the a, b, and c, knowing this, how it looks, everything, all the numbers, okay? Besides, of course, the x, the variable. We know x will have to be, okay, ready? A negative b plus or minus the square root of all this called the discriminant, b squared minus a 4ac, okay? And all this divided by all with the minus under, under the minus sign also. So you have to make sure there's a negative b all over this thing. Don't do this ever. This is a mistake if you do this. If you just, put the minus outside, that's going to be negative the whole thing. Don't do that. So all over 2a. Okay, that's our formula. That's quadratic formula. So let's apply it with what are our numbers. Let's check it out. We had, again, already x squared minus a 3x, or what was it, minus a 2x, remember? Minus a 3 equals 0. So our a is what? That's just a 1x squared. B is negative 2, right? Coefficient of x is negative 2. And what about c? The constant term is a negative 3. Be careful with the signs, SIGNs. Be careful. Okay? And so let's use the quadratic formula. All right? X is equal to, ready? Negative b, that's a positive 2 then, negative of a negative 2. Plus or minus the square root of what? Well, negative 2 squared is a 4, right? Negative 2 squared is a 4, not a negative 4. Minus a 4 times a 1 times a c is a negative 3. Let's keep this radical all over that. All over 2a, what's 2a? 2 times 1, right? Which is just a 2. So 2 times 1, 2a. And then that's equal to, be careful with the numbers, 2 plus or minus the square root of what? 4 minus a minus 12, that's a 16, because it's a 4 plus a 12, all over 2. Now that's what? That's 2 plus or minus 4 all over 2, okay. So if you do the minus, that's a what? 2 minus 4 over 2, or if you do plus, 2 plus 4 over 2, that's what it means, plus or minus, which is equal to negative 2 over 2, or 6 over 2, and that's exactly, look, negative 1 or 3. And let's not check now, we already did. We knew this would be the answer. We already have solved it before. So you don't have to do multiple ways to solve it, you just do it one way. Usually people prefer calculators, whatever, machines, they usually do this. Not the top approach, that's a little trickier, the factoring, but just directly plugging in numbers. The toughest part about this is, especially if you don't have a calculator, you may have to be careful with the numbers, the signs, the computation, right? Quadratic formula, we got it. And finally, there's one more way I want to show you how to solve these equations. You ready? Yeah, here it is. Let's do this way right here. So the other way is called completing. This is the toughest way for most students, completing the square, okay? And so this you don't actually need to have, don't have to have standard form. So what you can do is you make sure you have the x terms all on one side. That's my recommendation, because we eventually want to isolate the square. So x, the 3 can go on the right side, it's fine. You can say equals to 3. You can keep it on the left, it's not going to change anything, not much. but this is what we're going to do. Now, completing the square means the following. What do I have to do? So I take x, because I have x squared, right? 2x. With what number? What do I do right here? What box do I put? What do I put in that box right there to make it a negative 2x outside if I square it, right? Well, let's check this out. Let's do this quickly. So that means, by definition, that you do, what does it mean, squaring? X plus box, x plus box. We're going to plug in the box what we need to, okay? So look, what's x plus box, x plus box? Let's do the FOIL method. First terms, x squared. Outer terms, plus a box x. Inner terms, plus a box x, right? And what about plus a box squared of the last terms, okay? So it's very tricky, this completing the square. And you want to get combined like terms. You have x squared plus 2 boxes times x, right? Plus a box squared. Right. So that's what it is. How do I get a minus 2x? You know what I'm going to do? I'm going to put a minus. What we're going to do is we're going to put a minus. 1 second. We're going to put a minus 1, right? Think about it. And it's a trick. Let me make sure you can see it. 1 second. Make it a bit nice 1 here. So negative 1. Because then negative 2 comes out, right? Okay, and that's a negative 1. You have to put everything in the same in the box. Can't just cheat the box, right? Put in the same, it's like a weight. And you make, you're saying, you know what? If I put negative 1 right here, everything's going to be negative 1 in that box. Okay, so now x plus a negative 1, meaning x minus 1. In fact, let's check it out. X minus 1 squared is going to be x minus 1, x minus 1. And that is ultimately x squared minus a 2x. But hold up, minus 1, that's a what? That's a plus 1 there, right? Plus 1. Did we have a plus 1 anywhere? Did we have a plus 1? There was no plus 1 here, was there? So the way to get rid of that plus 1 is to take it away. In other words, x squared minus 2x, we're going to replace it with x minus 1 squared, yes. But to get just this, you see that, everyone? Get rid of the 1. Make it go back to that side. So subtract 1 from both sides here. And that's what's going to happen. I tell my students, whenever you see something like this, let me show you an example. X squared plus ax. What to complete the square is if you say this. It's x plus a over a over 2 and a square. Okay, that's the trick. And then take away that number that you have right there, squared. So then a squared minus a over 4 then, right? Just remember, that's the way you complete the square. I know this is tricky, the way it looks here, but that's the way it's always done. Okay? So, anyway, we have x squared minus 2x. We're going to focus on this now, that this is the same. They're equal. And let's go back to our color, orange color, and we have x minus 1 squared minus 1 for the top there. So, let me just rewrite this again so you can see. X squared minus a 2x equal 3. And we're going to rewrite this again as x minus 1, half of the 2 squared, take away that 1 squared minus 1. This is exactly the same on the left side now, it just looks different. Equals 3. Okay. Let me make a little nicer equal sign. Okay. Add 1 above sides, it's called isolate the square. Isolate square. So we already did complete the square. This is just one complete square now versus having a square and a linear term separately. Okay. And then isolate square meaning what? You want the square term by itself. So you say, you know what, x minus 1 squared, get rid of the numbers, is equal to now add 1 above sides, 4. And then we do the square root property. Now this is also like a common sense property. Square root property. Ready? Let me explain what that means. Think about it. If you had a number, you squared and you got number b, and a lot of students tell me, hey, you know what, it's a 2. 2 squared is 4. Yeah. What else? And sometimes they forget the negative 2. So square root property says if you have some number, let's call it like a z or something. Z. So if we have a number, let's say some kind of expression number, let's call it z. Z squared is equal to some number, like 4. So x minus 1 squared is equal to 4. Then z is going to equal to not only square root of n, okay, but plus or minus. Because if we squared it back, we would have gotten the same thing as we have above, okay? So we use that property and we say, you know what? If x minus 1 squared is 4, x minus 1 is equal to plus or minus square root of 4. That means that x minus 1 is equal to plus or minus 2, right? So negative 2 or positive 2. If x minus 1 is equal to negative 2, right? Or x minus 1 is positive 2. If x minus 1 is equal to negative 2, add 1 on both sides, x is a negative 1. Or if you add 1 on both sides here, x is equal to 2 plus 1, which is 3. Again, the same answers, because that's what we knew, actually. We knew that we were going to get that. The other two ways that we had solved it given us the same result. All right, everybody, I hope this was, not only educational, but also enjoyable, okay? Now, feel free to try any quadratic equation can be solved with the latter two ways. The factoring is tricky because some of them will not, as is said, will not factor. Honestly, by the fundamental theorem of algebra, anything will factor. It's just what's going to happen is you're going to have some square roots or some imaginary numbers, some weird things happening here and there. So I would just say, if it's a difficult problem, if it's not factoring, if this green method doesn't work, you go to this purple or violet method quadratic formula. And if you just want to mess around and get tougher at math, maybe go for this completing the square. All right, everyone. Thank you for watching.